So this one says, what angles have the same reference angle? Reference angle is the angle between the which axis? X-axis and the terminating arm, correct? So we're going to look. I like doing a sketch. It helps me out. I go 0, 90. If you didn't sketch, not a big deal. It just helps me. 360. I draw my 110. 110 is 70 away, or 20 away from 90, or 70 away from 180, so it's going to be somewhere like here. So this would be like 110, just to help myself out to visualize it. So my reference angle is 70. Because it takes me 70 to get to here, correct? Then, if I want, my reference angle is 70. In quadrant 1, it would be here. It would be here, which is 70. Remember the reference angle and the angle in quadrant 1 are always the same. They're equivalent. So in quadrant 1, this would be 70. In quadrant 2, it is 110. That's the one I gave you. In quadrant 3, if you have the reference angle, you go 180 plus your reference angle, so you get 250. And in quadrant 4, you do 360 minus your reference angle always, so you get 290. How'd you do on that one? Good? So in quadrant 2, the only one I didn't draw, in quadrant 2 you do 180 minus the reference angle, right? Quadrant 3 it's 180 plus, quadrant 4 is 360 minus, quadrant 1 it is the reference angle. Here it says, given the coordinate -5, 8, I gave you 2 separate questions to go here because I can go 2 separate ways with this exact same question, okay? So if I ask for the 3 trig ratios, this is x, this is y, I need r. It's -5 and 8. And then I always draw the reference triangle. So this is x equals -5, y equals 8. I get my r using Pythagorean theorem, and r is always what? You don't remember? R is always the longest one. It's also always positive because it's a length of measure, right? It's a radius. So r squared equals 8 squared plus -5 squared. R squared equals 64 plus 25. R squared equals 89. Can 89 break down into any perfect squares?
No.
No. So it's going to be positive root 89 because it's r. Now we do our 3 trig ratios, and I told you I'll give you the 3 trig ratios and Pythagorean theorem are going to be the 4 formulas you're going to get. So sine equals y, theta equals y over r, cos theta equals x over r, tan theta equals y over x, r squared equals x squared plus y squared, right? Those are the formulas you're going to get. So you don't have to memorize them. So sine theta equals y over r. So sine theta equals 8 over root 89. Problem is, I have to multiply by root 89 because I need to rationalize my denominator. So I'm going to get 8 root 89 over 89. If these 2 front numbers can reduce, you would do that, but they can't. So sine theta equals this. Cos theta equals x over r. So cos theta equals x, which is -5 over root 89. Then once again, you have to multiply by root 89, root 89. So I get cos theta equals -5 root 89 over 89. And then tan theta is your last one. Tan theta is y over x. So it's going to equal 8 over -5. That's your 3 trig ratios. Now, in this unit, if I ask you for an angle in standard position, you need to do 3 steps, right? Draw it. Reference angle. Get an answer, right? So 3 steps every single time. So if I want to draw it, I already drew it. It's right there, right? I'm going to redraw it here. So if I draw it, if I draw the coordinate, it's here and here. So I need that. Well, I need the reference angle in order to get that. How do I get a reference angle? Well, I do second sine or second cos or second tan of the positive fraction, correct? I have 3 options. When I have 3 options, you often do worse because you're like, I don't know which one to pick. It doesn't matter. Pick whichever one you want. I'm going to pick tan because tan doesn't have radicals, but you could have picked sine, you could pick cos, correct? So I know tan theta equals 8 over negative 5. But when I go to find the reference angle, I'm going to do theta equals tan neg 1 of 8 over 5. I always do the positive. And what do you get for a degree? Did anyone get a degree? You could have done it in sine and you could have done it in cos. You'll get the same answer. Yeah. 58. Everyone else get 58? You could have done sine, you could have done cos. You should get the same answer. That's the point. It doesn't matter which trig ratio you pick. Okay? I picked tan, first off because it doesn't have radicals, but second off because I didn't think too many people would pick it because you probably picked sine or cos because it came first. Proving that it doesn't matter which one you pick, you'll get the same reference angle because we're taking the positive of each. All right. So the reference angle is from the x-axis to the terminal arm. So this is 58. Wait, I'm in quadrant 2. So this is step 1. Step 2. When I'm in quadrant 2, I follow the same steps always. Quadrant 2, theta equals 180 minus the reference angle. So I'm going to get 112, 122. Oh, it's not 60. 122. Because 180 minus 60 is 120, and then you have to add 2. So theta equals 120. Okay. Number 3. So here it says, I give you a trig ratio. Now this is what I could do. There's 2 things. I can give you a trig ratio, and I can ask for a trig ratio, meaning you're going to draw the reference angle triangle, correct? Get your trig ratio. Find your third side. Or I could give you a trig ratio and ask you for the angle in standard position. Then you do the 3 steps, right? Totally different. So if it's a trig ratio, ask you for another trig ratio, you do the reference triangle, find third side, give trig ratio. If I give you a trig ratio and ask you for the angle, you're going to do 3 steps. Draw, reference angle, answer. So it's 2 separate, totally different questions, look very similar. So here we're going to look at this one. Given tan theta equals this, determine the value of sine theta. I'm asking for a trig ratio, right? So if I'm asking for a trig ratio, I'm going to have to find the third side. So tan theta is positive, and it's between 180 and 270. This one's nice. So I literally just said it's in here, right? I draw my reference triangle. And tan is y over x. What the heck is my x? It's just a 1. Now, I tricked you out and put it in this quadrant for a reason. Because people will say y equals root 3 and x equals 1. Is that possible in quadrant 3? For them to be positive? No. This here's a what? Negative x. This here's a what?
Negative y.
Negative y. And what's a negative divided by a negative?
Positive.
A positive. So it'll look like it's positive, but they're actually both negatives. You have to watch yourself. Okay? So this is actually y equals negative square root 3. This one is x equals 1. And then I need to find r, and r is always positive. Oops, this one's x equals negative 1. Because technically we have a coordinate here. It's at negative 1 and negative root 3. So when you're in that quadrant, you have to watch your x and y's are both negative. So we define our third side. So r squared equals negative 1 squared plus negative root 3 squared. R squared equals 1 And then when you root a square or square root, they cancel. Negatives always will become positives. So I'm going to get plus 3. So r squared equals 4. So r equals plus or minus root 4. But r is always positive and root 4 is 2. So I'm going to get positive because it's r, and the square root of 4 is 2. So r equals 2. And then I can find sine theta. Sine theta equals y over r. So sine theta equals y, which is negative root 3, over r, which is 2. So that's a trig ratio asking for a trig ratio, right? If you have a trig ratio and you're asking for a trig ratio, you have to draw the reference angle triangle, find the third side, give me the trig ratio. As opposed to number 4, which I give you a trig ratio and then ask you for the largest value of theta. Whenever I'm asking for theta, you have to do 3 steps. Draw, reference angle, answer. Draw, reference angle, answer. Draw, reference angle, answer. Okay? So this when I ask you for a trig ratio, you draw, find third side, give me trig ratio. When I ask for theta, you draw, you reference angle, answer. So these all have 3 steps. This one's draw, but reference triangle. 2, find third side. 3, give answer. So they both have 3 steps, but totally different steps. Okay? So this one we're going to draw. How do we draw this? Well, we know it's between 0 and 360. Remember when I told you it's between 0 and 360 and you're getting 2 thetas? You're going to get 2 answers, remember? If I ask you for theta and I just go from 0 to 360, you're going to get 2 answers. How the heck do we know where to draw them? Well, cast. So we need sine, negative. Where's sine negative? Where S and A both don't exist is where sine is negative. So sine is negative here in T and here in C. Because we need sine negative. Now I have the 2 arms. If I get my reference angle, it's easy. I go 180 plus reference angle, 360 minus reference angle, and I'll have answers, right? So some of the hardest part is actually just figuring out where the heck to draw it. 2, reference angle. So I need reference angle. How do I do that? I do theta equals sine neg 1 of positive 2/3. What do you get as an answer? Sine neg 1 of positive 2/3. Yeah. 42 degrees. Everyone get that? Should I? Okay. Then, this is 42. And this is 42. So I'm going to get theta equals 180 plus 42, which is 222. And theta equals 360 minus 42, which is 360 minus 40 is 320, but then I minus 2 more, so 318. But which one's actually the answer? I want the largest value. So which one's actually the answer? 318. 318. That's how I can ask it in a numeric response. Yeah?
But if you had to like show the work for like 222?
No, absolutely not. I just wanted to prove that we can get 2 answers, but we're really only looking for 1. Yeah, absolutely would not have had to show that. So, number 5. Determine if this point is on the unit circle. What's the most important part of that? On the unit circle, right? If it says on the unit circle, I told you to highlight it or underline it. And we're going to go x squared plus y squared must equal 1. And this is my x, and this is my y. And then I just plug it in. So I'm going to get negative 4 over 5 squared plus 3 over 5 squared equals 1. So I get 16 over 25 plus 9 over 25 equals 1. And then 16 plus 9 is 25, all over 25, right? When we add fractions, we have common denominators, so this will be over 25, and then 25. So I get 1 equals 1. So I just proved that, yes, this is on the unit circle. So I say negative 4 over 5 and 3 over 5 is on the unit circle. So when I study at night, I have this review sheet in front of me. Can I not just cover up the work and try the question over? Till I can do them without thinking, what am I supposed to do? Because often, Trig, you'll sit there and be like, looks lovely, don't know what the heck I'm supposed to do right now. Okay, we don't want that for tomorrow. We want you to look at it and be like, ah, yes, this is what I do. Okay? And we're going to flip over. Next one's very similar to the last one. It says, if negative 6, 7y is on the unit circle, that means x squared plus y squared equals 1. In quadrant 3, why would they write that? What does quadrant 3 tell me? Yeah.
That's going to be a negative.
It's going to be a negative. Because I need, if it's in quadrant 3, that means it's down here. And what's y down here? Y is negative. So that's what that tells me. Because when I take the square root, when I use that formula, I'm going to get plus or minus. So I need to know, is it positive or is it negative? And if we're looking for the value of y, we can just rearrange it by subtracting the x squared over. So I can go I can go y squared equals 1 minus x squared, and then plug it in. So I get y squared equals 1 minus negative 6 over 7 squared. Y squared equals 1 minus 36 over 49. Your calculator could be doing this for you. I'm going to do it again. So I get y squared equals 13 over 49. And then I square root, plus or minus. Because it's in quadrant 3, I know it's minus. What did I tell you to do with the square roots when one of them is a perfect square?
Do them differently.
Do them differently. Split it up. So I'm going to get square root 13 over square root 49, which is 7. In grade 10, you were taught you can split them. For 7, 8, and 7 and 8, let's say, I'm giving you a trig ratio, asking you for an angle. Give you a trig ratio, ask you for an angle. What do I have to do? The 3 steps, right? Give you a trig ratio, ask you for an angle. I have to do first step, draw. Second step, reference angle. Third step, answer. Okay? Trig ratio, angle. Trig ratio, angle. I'm going to get you to try 7, 8, and 9 if you haven't already. At 10, we're going to go through them in, I don't know, probably 10 minutes. And then we're going to do the backside. Yeah. 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 Mm-hmm. Mm-hmm. Yeah. Mm-hmm. This one asks us for theta. So the reason why I gave you 2 trig ratios here is you could use either one to get the reference angle, but the 2 trig ratios are so that you know where to draw it. Okay? Cos is just x, sine is just y. So I want where x is positive and where y is negative. So it's here. I don't know where I was going to draw it, but it's here. Now, we can go through all the work, or we can recognize, hey, that's off the unit circle. Where is cos root 3 over 2? And where is sine negative a half? Where is that happening at? It's really not here, it's like here. It's terribly drawn. It's going to be at 330. right? 3:30? Is that what you're going to tell me? I only noticed your hand after I get the answer. Terrible teaching moment. 3:30. Yes. If you don't notice that, you could go, okay, I'm going to use cos. Reference angle. Theta equals cos neg 1 of root 3 over 2. And that's going to give me 30. And then I know I'm in quadrant 4, so I do 330. And by 330, I mean 360 minus 30, which is 330. The next one says, if cos theta equals that, so we're going to do this, and we have tan this. So when I give you this and a trig ratio, we have to use cast. So I have cos positive, so I need to be where c's are existent, so that's in quadrant 4 and quadrant 1. And I need where tan is negative. So where is c exists, but t doesn't exist? C exists, but t does not exist. Yep.
In bottom right.
Yeah, bottom right, so in quadrant 4. So we're here. So I found out where to draw it. Step 1. Step 2, I need the reference angle. So it's going to be cos of theta equals cos neg 1 of 0.657, the positive. And what do you get for an angle? 49. And then quadrant 4, I do 360 minus the reference angle. So that's like 360 minus 50, which is 310 plus 1, so 311. Number 9 is that one that shows you how I could give you the same question but ask two separate things, right? So I can tell you tan theta equals negative 4 over 3 in quadrant 2, the value of sine theta. So I'm going to give you a trig ratio, asking for a trig ratio. When I give you a trig ratio, ask you for a trig ratio, I draw it in quadrant 2, and I draw a reference triangle. Tan is y over x. So this is 4 and this is 3, and one of them has to be negative, because the negative's sitting out front. Which one of these has to be negative, the 4 or the 3? Yeah. The 3, because x is negative here, but y is positive. So I get x equals negative 3, y equals 4. I have to solve for r. So r squared equals 4 squared plus 3 squared. R squared equals 16 plus 9, which is 25. Square root plus or minus. So r equals plus or minus 5, but because it's r, it's positive 5. So step 1, draw. Step 2, find the third missing side, right, when I'm looking for trig ratios. Step 3, find the trig ratio. Sine theta equals y over r. Sine theta equals y, which is 4, over r, which is 5. Done. So I can give you a trig ratio, ask you for a trig ratio. Or for B, I can give you a trig ratio and ask you for an angle. I give you a trig ratio and I ask you for an angle. You do the 3 steps. First step, draw. It's in quadrant 2, so it's here. And it started here, and it rotates here. Step 2, get the reference angle. So theta equals tan neg 1 of the positive, so 4/3. What does theta equal? Anyone get it? Second tan of 4/3. If you didn't get it, you should try it, because you're running your calculator tomorrow, aren't we? Yeah. 53. So that's this angle. When we're in quadrant 2, we always do 180 minus our reference angle. Look at 127. What's the problem with number 10? Anyone know?
There's a 2.
There's a 2 in front, and we can't do reference angles unless we actually have cos, sine, or tan, right? So the first thing we have to do is divide by 2. So we get cos theta equals negative a half. So this is, I give you a trig ratio, I ask you for an angle. We do the 3 steps. Draw, reference angle, answer. Draw, reference angle, answer. Okay, I'm going to draw. All it says is between 0 and 360. If all it says is between 0 and 360, I will always get 2 answers, right? 2 answers. So I want where cos is negative a half. So I want where it's not C. So it's going to be here and here. Because I want cos negative. Because it's cos negative. Now 2. Reference angle. 80 equals cos neg 1 of a half. You type that in, you should get 60. Also, this is cos x equals negative a half. You can look for on your unit circle when it's a half, or root 3 over 2, or root 2 over 2 is the answer. You can just find the answers off your unit circle as well. You can look where x equals negative a half, which is here and here. You could just find it off and not do 1, 2, and 3. Not do the steps at all. Just give me answers. So this is 60. So is this. In quadrant 2, I do 180 minus the reference angle. And I get 120. In quadrant 3, I do 180 plus the reference angle. And I get 240. If you look at 120 and you look at 240, you'll see that x is negative a half. You can just pull them off there. Number 11 on the back will be a bonus question. I'm not going through it. I did 1 in class. You can work on it. Try it out. It will be a bonus question on the test. So we're going to number 12. So we did do one question like this. We had to let m equal the signs. Then we had to factor it. Then we had to solve for both signs. And we got answers. So you can try and work on it tonight yourself. It is a bonus mark. That question is a bonus question. Tell us how you really feel. Sine of 330. So we want the exact value of sine of 330. So if it says exact value, this says go look at your unit circle. This is where your unit circle is going to come in handy. So sine is what on the unit circle?
Y.
Sine is y. So sine is y. So I go to y at 330, and it is negative 1/2. Done. So we're literally just looking off the unit circle for these. So I go to 330, I go to the y, and I write it down, and I move on. Did everyone see that? Because these should be easy questions, and they're ones that are not answered. Like 3-step questions you guys do, and then these are like, I don't know. Right? So these should be your easy marks. Tan of 240. Does tan come right off our unit circle? No. But tan is y divided by x, correct? So we actually have to do steps when it's tan. So I go to 240, and my y at 240 is negative root 3 over 2, I believe. And my x at 240 is negative 1/2. That's the case, right? So I'm going to get negative root 3 over 2 times 2 over negative 1. And the 2's cancel. And I'm left with negative root 3 over negative 1. Which is a good answer, but what's the actual answer? Yeah. Just root 3. Because the negative divided by negative is just root 3. Okay? So you're going to finish these off. You have about 5 minutes. The coses and the sines should be quick answers. The tans, you have to do y divided by x. So tan 135 is y divided by x. Tan at y at 135 is root 2 over 2. X at root 35 is negative root 2 over 2. 135. And when you divide two numbers that are exactly the same together, you get 1. When you divide two numbers, one's positive, one's negative together, you get negative 1. Tan 150 is one of the harder ones because it's actually a 30-degree reference angle, and they're the hardest with tans. So it's y divided by x, which is positive a half, divided by negative root 3 over 2, because it's y divided by x. So I get a half times 2 over negative root 3. These cancel, the 2's cancel, and I get 1 over negative root 3. The issue is you can't have a negative or a root in the denominator, so you have to rationalize, just like we've had to do whenever we have roots in denominators. So we have to multiply this one by root 3. If you just type these into your calculator and give me decimals, you're going to get no marks tomorrow, sadly. So please don't be that person. I get people going tan 150, and they give me the decimal. Decimals are not exact values, right? So sadly, I can't even give you a mark. So don't be that person. Cos of 90. I go to 90 and I pull the x off. At 90, what's my x?
0.
0. Sine 270. I go down to 270 and I pull off my y, which is?
Negative 1.
Negative 1. Didn't mean to make that too much. So, sine of 210 plus cos 120. The great thing about these, as long as they're sines and coses, they'll always have common denominators. And tomorrow on your test, I'll always give you sines and coses to add and subtract. I'm not going to throw a tan at you in here, but I can give you a tan where you have to find it, right? But I won't be mean enough to give you tans in here. Next year, there'll be tans, cotans, cosecants, secants, whole bunch. It's not as nice. So sine at 210, I go to y at 210. My y at 210 is going to be negative a half. Cos at 120 is going to actually be x at 120, which is negative a half. Should get negative 1. Yeah. Then we go cos of 135. So I go to 135. It's going to be negative because x's are negative there. Cos at 135 is going to be negative root 2 over 2 because I pull the x off. Then a minus sign. Then I go to cos of 330. So I go to 330, which is in quadrant 4, and I take the cos off of that, which is actually positive root 3 over 2. Now they have a common denominator because I said if it's coses and sines, you're going to have 2's, right? So this one's going to be all over 2, and then we just rewrite the top. Negative root 2 minus root 3. That's it. If you turn it into a decimal, you've ruined all your work because it says exact value, right? If you type it in and give me a decimal, you just had it perfect, you should have boxed it and walked off, but you did more work. So stop yourself, okay? Exact value means go to your unit circle, get some numbers, don't punch it into your calculator. Then sine at 315. We go to 315 in quadrant 4. We look at the y at 315, which is negative root 2 over 2. Then we add to it sine of 120. So we go to quadrant 2. We find 120. We take off the y because it's sine, which is root 3 over 2. They're both over 2, so I can put it all over 2. Rewrite the top. Negative root 2 plus root 3. Box it and be happy. Don't work your butt off trying to wreck that or change it because you're doing bad things if you do anything after that. Okay? Like I said, number 10, I believe it's number 10. 11?
Yeah.
11 is a bonus question. It will be the question. It is the bonus question. So you can choose to do it, work on it. Or if it's overwhelming to you, be like, no thanks, not today, Lepp. I'm not doing it. Okay? It's from next year's curriculum.